Hi guys, in this opportunity I will present about analysis of variance assumption. ANOVA is a statistical analysis that examines the difference in means between groups. Group here can mean group or type of treatment. ANOVA was discovered and introduced by a statistician named Ronald Fisher. ANOVA stands for Analysis of Variance. It is a statistical test procedure similar to the t-test. However, the advantage of ANOVA is that it can be test the differences between more than two groups, in contrast to the independent sample t-test, which can only test the difference in the mean of the two groups. Assumptions for hypothesis testing based on the single factor ANOVA model are actually related to the residual value or error. Many references state that single factor ANOVA is quite reliable for this assumption. For example, the F-test remains reliable and reliable even though the assumptions are not met. However, the level of reliability is very difficult to measure and also depends on the sample size that must be balanced. The F-test can be very unreliable if the sample size is not balanced, especially if it is added to the distribution of data that is not normal and the variance is not homogeneous. Therefore, it is highly recommended to first check the ANOVA assumptions before proceeding to the analysis stage. Next is ANOVA Test Concept Foundation. Analysis of variance or ANOVA is used to see the average comparison of two or more groups. This facilitates the analysis of several different sample groups with minimal risk of error, called analysis of variance, not analysis of means, because the test is done by comparing the variances. By comparing the variances, it can be seen whether there is a difference in the mean of three or more groups. Thus, before conducting an analysis of variance, we must first check whether the data has met the basic assumptions of the analysis of variance or not. What is it used for? ANOVA is used as an analytical tool to test research hypotheses which assess whether there is a difference in means between groups. The final result of the ANOVA analysis is the F-test value or F-count. F-value calculate this which will be compared with the values in the table F. If the calculated F-value is more than F-table, it can be concluded that accepting H1 and rejecting H0, or which means that there is significant difference in the mean of all groups. Next is ANOVA function. The ANOVA test is used to compare the population averages to find out significant differences between two or more data groups. There are two types of ANOVA tests, namely one-way ANOVA test and also two-way ANOVA test. According to the Statistics Solutions website, one-way ANOVA functions to analyze data that has only one independent variable or is due to one factor. The two-way ANOVA analyzes data that has two independent variables or has a second factor that affects the condition of the population. And next is features of ANOVA. Its characteristic is the presence of one or more independent variables as a causal factor and one or more response variables as a result or effect of the factors. An example of research that can illustrate this explanation: is there any effect of the type of fuel on the life of the engine thorax? From the title, it is clear that fuel is the causative factor, while the age of the engine thorax is the result or effect of the factor treatment. Another characteristic is the response variable on a ratio or interval data scale, or numeric or quantitative. ANOVA is one of various types of parametric test because it requires a normal distribution on the dependent variable per treatment or a normal distribution on the residuals. This normality requirement assumes that the sample is taken at random and can represent the entire population so that the research results can be used as generalizations. However, its uniqueness is that this test can be said to be relatively robust or immune to these assumptions. Next is ANOVA test requirement. According to Donald H. Saunders, in the book Comparison of Three or More Sample Means, Analysis of Variance in 1990, there are assumptions that must be met to perform the ANOVA test, namely, first, random sampling. Samples are independent and free, meaning that individual samples are taken randomly from each population or data group. Second, multivariate normality. Distribution of symptoms for each population or data groups is normal. To get data with a normal distribution, the number of samples can be increased or a normality test can be done first. Third, homogeneity of variance. Every population has the same variance if the difference should not be too significant. The similarity of variance can be known through variance testing. Next is ANOVA test assumptions. First, the population must be independent and the observed data must also be independent of the group. That is, each sample is not related to other samples. Second, the population studied in the test must be normally distributed. This normality must be met because in principle the ANOVA test is a mean difference test. It is the same with the t-test or z-test. The sample must of course be taken from the normal population and try to have a large sample. Normality can be measured by normality tests such as chi-square or Lilliefors. Third, the population must have the same standard deviation or variance. This variance similarity will be related to the f-test that will be carried out later. If the variance in the population is not the same, then the f-test cannot be carried out. The last condition is that if the sample taken from a population is independent, the sample is taken randomly. Next is hypothesis in ANOVA. First, the population must be independent and the observed data must also be independent of the group. Second, the population studied in this test must be normally distributed. Third, the population must have the same standard deviation or variance. The last condition is that if the sample taken from a population is independent, the sample is taken randomly. Next, to perform the ANOVA test, several assumptions must be met, namely, first, the variance between groups must be homogeneous. Second, the data of each group is normally distributed. Third, the sample comes from an independent group. And fourth, components are additive. The first assumption must be met when sampling is carried out randomly on several or more than two independent groups, where the value in one group doesn't depend on the value in the other group. Meanwhile, the fulfillment of the second and third assumptions can be checked if the data has been entered into the computer. If this assumption is not met, the data can be transformed. If the transformation process cannot fulfill this assumption, then the ANOVA test is not valid. Next is ANOVA test steps. Fulfillment assumptions. The first step in testing ANOVA is to fulfill the three assumptions that are the test requirements. Calculating the mean. The next step is to calculate the mean of each group. After completion, it can also be calculated the overall mean or total mean. Calculating the deviation. Next is to calculate the deviation from the group mean value as well as the total mean. This will show the variability of the overall sample data. Then, calculate the mean squared value of each group and the total. After the mean squared result is obtained, it can be calculated the degree of freedom for both the intergroup variables and the in-group variables. Calculating F-ratio. The next step is to find the F-ratio value by comparing the mean squared value between groups and the mean squared value within the group. Next, comparing the null hypothesis. Next is to calculate the deviation from the group mean value as well from the calculated F-ratio value. It is then compared with the F value in the table. If the F-ratio value is greater than the table F value, the null hypothesis is rejected. So it means that there is a significant difference between the mean of the data groups as the total mean. This will show the variability of overall sample data. However, if the F-ratio value is less than or equal to the F-table value, then the null hypothesis is accepted. This means that each data group has the same mean value or there is no significant difference between the data groups. In the ANOVA test itself, there are two types, namely one-way ANOVA and two-way ANOVA. One-way analysis of variance or ANOVA is a hypothesis test in which one categorical variable or single factor is considered. It is a technique that allows us to make comparisons of the mean of 3 or more samples with the help of the F distribution. It is used to find out the difference between its different categories which have several possible values. While two-way ANOVA, as the name suggests, is a hypothesis test in which the classification of data is based on two factors. For example, two classification bases for sales made by a company are the first based on sales by different sellers and the second by sales in different regions. It is a statistical technique used by researchers to compare multiple levels of two independent variables involving multiple observations at each level. One-way ANOVA is based on following assumptions. First, normal distribution of the population from which the sample is drawn. Second, the measurements of the dependent variable is at the interval or ratio level. Third, two or more of the two groups of independent categories in the independent variable. Fourth, sample independence. And fifth, homogeneity of the population variance. Next is assuming two-way ANOVA. First, normal distribution of the population from which the sample was taken. Second, measurement of the dependent variable at a continuous level. Third, two or more of the two groups of categories independent of two factors. Fourth, category independent groups must be in the same size. Fifth, observation independence. And sixth, homogeneity of the population variance. That's all. Thank you for your attention.